Welcome back. We're doing pages 18 and 19 in this section of the video. So we just learned, I lost my pen. We just learned on the previous page that probability of A times probability of B is equal to the probability of both. So now we have two ways, because one wasn't enough, we have two ways to determine if two events are independent. One is when we have, it's called conditional probability, and that means we have the word given in the problem. So if you see that, then use conditional probability. Now the new way is called the multiplication rule, where it's the probability of both, and that would equal the probability of A times the probability of B. Just like with conditional, if those things match, then the two events are independent. So let's take a look at exercise number 4. College freshmen were surveyed to determine whether they were using an iPhone and an iPad. The findings of the survey are displayed in the table. So on the top, we have iPad versus no iPad. And then on the side, iPhone versus no iPhone. Based on the survey results, so now it's telling us use the multiplication rule to determine if the event has an iPad and has an iPhone are independent. So we're looking to see if having both affects or has some type of change in the probability. So what I've got here, probability of an iPad and an iPhone. So I take the probability of both, divide by the total. And I got, because I put this in my calculator as a fraction, 31 over 87. But if you do a decimal, it's 0.356. So that's what I've got here, okay, 31 over 87. And then on the other side, I multiplied the two together. Probability of an iPad times the probability of an iPhone. So probability of an iPad is 186 over our total, 348. Probability of an iPhone is, where's our phone? 232 over 348. So when I put all of this in my calculator, I ended up with the same answer. So those two events are independent. One does not affect the other. So just to kind of hit home on this, we used multiplication here for part A. Now for part B, we're going to use the same scenario, but conditional probability. Remember, conditional probability means we're doing given. So I did it two ways. Probability of an iPhone is equal to the probability of an iPhone given iPad. And you can see I did probability of an iPhone is 232 over 348. And here's our given. iPhone is 124 given iPad is 186. When you simplify those fractions, they come out the same. And then over here, instead of starting with the iPhone, I started with the iPad. Too many I's. Probability of an iPad gives you the same result as the probability of an iPad given an iPhone. Make sure when you do these problems, you simplify your fractions. If you don't, it'll look like you have two separate things. So on this last problem on this page, we're going back to our students who have asthma and live in a household where at least one person smokes. Okay, so we've been doing this a bunch of times so far this unit. So here's our directions. Use the multiplication rule. We've previously done this with our conditional probability, our given statements. So this is use the multiplication rule to determine if the events at least one household member smokes and the student indicates he or she has asthma. See if they're independent. So what I did here, probability of smoking times the probability of asthma. And these are totals. We're not doing givens. So probability that somebody smokes is 395 over 938 times somebody having asthma, 183 over 938. And I got 0.082. Then over here on the right side, I did the probability of both. 113 over our total, and I got 0.120. They're not the same. They do not simplify to be the same number, so they are not independent. So now on page 19, this is where hopefully you can see that using the multiplication rule could make your life a teeny bit easier than having to make a two-way frequency table. So right now we're looking at exercise number 6. The probability that Stephanie jogs by the lake on any given day is 40%. And remember when we did exponential functions and we had to make our percent number usable? I'm going to use 0.40. The probability that it rains on any given day is 30%. We're going to use those numbers. Now, the question says, if the probability she jogs by the lake and the probability it rains are independent, we're going to find out something missing. What's the probability she jogs by the lake and it rains? So we know they're independent. So what we can do is just multiply those two probabilities together. So 0.40 times 0.30, our probability is 0.12. Now we could have figured this out using our two-way frequency table. So we know probability she jogs is 0.40. Probability it rains is 0.30. And we know the total is always 1. So because this is independent, they told us it was. Everything is in proportion. So what I did over here was I said this value over 40, the x we don't know, is in proportion to 0.3 over 1. And then I solved my little equation. I cross multiplied and I got 0.12. This last question goes along with our last lesson, so just kind of a little foreshadowing. In a board game, a die is tossed and a coin is flipped. Use common sense to explain why getting a 5 on the dice and getting head on a coin flip are independent. No matter what you roll on dice is not going to affect your coin. So what is the probability of getting a 5 on the dice and head on the coin flip? So they are independent. When we're looking for two probabilities where they're joined, we can multiply them. So probability of a 5 is 1 over 6 because there's 6 sides on the dice. Probability you get heads is 1/2. When you multiply them together, you get 1 over 12.